In this video, we're going to see the log object. Here we can see the sequential specification of the log object. So the log object supports two operations, an append operation and a get log operation. So internally in this sequential specification, we can think that the log object contains a list. Whenever we append something, we append this in the underlying list. And when we call get log, what we do is that we go through this list, retrieve all the elements from the list, store them in this temporary result array, and then return this result array, which corresponds to the log. So let's say if somebody called append 2, append 6, append 7, and then get log, what get log will return would be 2, 6, 7. And now let's see another object, the Fetzernad object. And here we can see the sequential specification of the Fetzernad object. So we consider that we have this register that is 0, and when we call Fetzernad, we store the value that is being contained in our inold, then we increment the value by 1, and then we return the old value. In this video, we're going to answer the following question. Is it possible to implement a linearizable and weight-free log object using read and write registers and Fetzernad objects for any number of processes? So we described before the sequential specification of the log object. The log object has an append and a get log operation. And we are wondering whether we can implement this log object out of read, write registers and Fetzernad objects. So what do we know about Fetzernad objects? What we know from class is that the consensus number of a Fetzernad object is 2. And what else do we know from class? We know that the log object rings a bell, kind of reminds us of a universal construction, because if we had this log object and we want to execute an operation, let's say, we could just append the operation in this log, and then some other process could append some other operation, and so on and so forth, and then we can just call get log and execute these operations on this log. So we have this idea here from the log object that it rings a bell of a universal construction, it reminds us of a universal construction, and we also know that the consensus number of a Fetzernad is 2. But if we could get the universal construction out of a log object, this might hint to the fact that the log object itself has a consensus number higher than 2. So implementing it just by using Fetzernad objects and read and write registers which have consensus number 2 and 1 respectively would seem to be impossible. Which means that it seems unlikely to be the case that we can implement a linearizable and weight-free log object just by using read and write registers and Fetzernad objects. Let me just say that this problem appeared in the final exam of 2018, and although the answer is no, a couple of students said yes and showed a bogus implementation of a log object just by using read and write registers and Fetzernad objects. So how can we show that it's impossible to implement a log object out of read and write registers and Fetzernad objects? We can do the following. We can devise a consensus algorithm for any number of processes that internally uses the log object and read and write registers, and therefore show that the consensus number of a log object is infinity. If this is the case, then it can definitely not be implemented by read and write registers and Fetzernad objects. Okay, so how would such a consensus algorithm work? It's actually pretty easy. So all processes would share a log, which is a log object. And then we reuse this idea of winning that we show in previous videos. So when a process wants to propose something, it's first going to append its value in the log, and then it's going to retrieve the log. And the value that wins is the first one that was appended in this log. So the first process that called append will manage to be the first one that has its value in the first position of the log. So we just return this, and that's it. To conclude, this was a really easy problem. but we have to always be careful and think about what is being given, what do we know about the Fetzernad object, what's its consensus number, what does the log object reminds us of, could we use it in some other way, and so on and so forth.